All right, I'm going to go ahead and do another example of the same as example 2a, which was another motion problem. Man, that was a 15-minute chunker. Man, just do one problem, and it's really easy just to get lost in the beginning. And so I'm just going to do another one. And so I suggest that you probably, read the textbook examples as well. Try to follow along with those ones, and also maybe watch the other videos that the textbook provides. Because these motion problems are by no means simple. They're not quick. They're many steps. But hopefully I'm able to explain to you how they work and how you derive these equations here. So let's go and give another shot at it, solving a motion problem. All right, so we have a small fishing boat that averages 18 miles per hour in still water. All right, so it's a little putt fishing boat, 18 miles an hour, not too bad. And it takes the boat 9/10 of an hour to travel 8 miles upstream and return. All right, so its total time is 9/10 of an hour, and it travels 8 miles up and then 8 miles back down. Find the rates of the currents. All right, and so let's go ahead and begin here. And actually, probably we should always start with what is x. All right. So let x be equal to, and you always know what x is by looking at the last sentence, or basically what is it that we're trying to find? We're trying to find the rate of the current. So let x equal the rate of the current. Okay, so we want to know how fast is the water going down the stream, or is it going, well, it's not going up though, so we just want to know how fast is it going down. All right. Okay, so what we want to do here is we have a river that's, or is it a river? I don't know. It's like just, it's okay, like a little stream here. Okay, so we have a stream where one of them's going up. Okay, so here's our little fishing boat. Hi, matey. I like to get little fishies. Aye. All right, so that's going up. And then we have the stream that's going down as well. Okay, and I'll just kind of go like this. Okay, so we have it going up, and then we have it also going down. So this is going up, and this is going down. Using dirt, distance equals rate multiplied by time on both sides here. Let's go ahead and fill in what do we know here. Okay, well, we know that the total distance that you travel going up the stream is 8 miles. So we know that 8 equals, so I'm replacing the d with 8, equals the rate. Okay, so how fast is this dude going? Well, the guy in the boat is traveling 18 miles an hour, right? So that means if he's going up, he's going to be traveling 18 miles an hour, but wait a minute, the current is going against him though, right? So that means you have to subtract the current. But do we know what the current is? No, that's what we're trying to find, right? So we're going to subtract x. So he's traveling up, which is 18 miles an hour, but then he's being pushed back. He's slowing down based off of the minus x, and x represents the rate of the current. Okay, so this whole thing right here represents our r. So distance equals rate multiplied by time. We don't know the time yet. Coming over here, again, d is 8 equals. Now the rate is he's traveling 18 miles an hour, and now the stream's going down though. And since the stream is going down, that means that he's going to be doing plus. So 18 plus x, okay? Because he has a little boosties on his, maybe like a little bit of Nas on his, little motor. It's kind of cool there. And then multiply that by time. Okay, so what we want to do now is we want to multiply, or actually solve for t for both of these. Let's solve for t. So I'm going to divide both sides by 18 minus x. And basically we're doing the same process as we did last problem here, okay? So those cross out, and I get t equals 8 over 18 minus x. And then over here, let's solve by dividing 18 plus x. So 8 over 18 plus x equals t. Okay, and again, this is the t going up, and this is the time going down. Okay, so if I take the t that goes up, the time it takes to go up, and the time it takes to go down, that total time should be, bing, it takes a total of 9/10 of an hour. Cool. So that means we have an equation. We could do the t plus t, or the t up and plus the t down equals 9/10. But we know that the t has specific values here. This one right here is 8 over 18 minus x plus the other time it goes down, and that equals the total time 9/10. Okay, so this represents right here the time that it went up, this represents the time that it went down, and this represents the total time. So time up plus time down is the total time that dude was gone. And now let's go ahead and we're going to solve for x now. And we're going to do that by using what we learned in the first two examples. Okay, so let's first go ahead and find our lowest common denominator. And again, the lowest common denominator is when you multiply all the factors together. So it's going to be 10 times 18 minus x times 18 plus x. All right. So what do we do with this LCD? Well, we multiply everything by this. Okay, so everything's going to get multiplied by 10 times 18 minus x and 18 plus x. All right. So let me get a lot of whiteboard space here. Takes a lot of room. Okay, so let's multiply this guy by 10 minus 18x times 18 plus x. So 10 times 18 minus x times 18 plus x. And we're going to multiply that by 8 over 18 minus x. Okay, so I just multiplied this whole thing by our LCD. Okay. Plus, multiply by the LCD again. 10 times 18 minus x times 18 plus x. It's like the never-ending problem, man. But never-ending nerdiness, that's what I'm talking about. Times that by 8 over 18 plus x. Okay? Equals, now multiply this guy by 10 times 18 minus x times 18 plus x. So let me see if I can fit this all in your 10 times 18 minus x times 18 plus x. Oops. And that whole thing gets multiplied by 9/10. Woo, Billy! All right, now we go ahead and be like, wata. And that's cool because now the denominators cancel. Let's go ahead and just multiply 10 and 8 first and just get 80. And then we'll just drop this down. And then we'll multiply that on our next line. Plus, wata. So let's multiply 10 and 8 and get 80 again. And then get 18 minus x. And coming on to the right side, get rid of the 10s. And I get this guy right here. So I'm going to have 9. And if I do the FOIL method right here, and you could do that, I just will do that quickly here. If you do the FOIL method, you would get 229/16 minus x squared. Okay, so if you did the FOIL first, outside, inside, last, then you would get this guy. Okay, so let's multiply these all out. 80 times 18 will give us 1440 plus 80 times x, 80x, plus 80 times 18 is 1440, and then 80 times negative x, negative 80x. Woo! And coming over here now, we're going to multiply now by 9 and 29. One say that's a big number there. So 9 times 20. Hold on, there's something's not looking right again. Hold on. And I can't start this over again. That was a long problem to start all over here. Let's see what happened. What did I do here? Oh, I see what happened. Okay, so when I do the FOIL, I actually already multiplied by 9 right there. So let me just go back here. When you do FOIL, this is actually just 9 times, and then the FOIL part right here is just a 324 minus x squared. Okay, so now when I distribute the 9 right there, that's going to give us 2916 minus 9x squared. All right, if you need to pause it real quick just to make sure that you get where we're at. I don't want you to just keep going here not knowing what we just did, but I just did the FOIL right here. 18 times 18 is 324. 18 times x, positive 18x, negative x times 18, negative 18x, and then negative x times x is a negative x squared. And notice that the 18x and the 18x, they cancel out because one's plus and one's minus. So that's why I get 324 minus x squared. Okay, so let's see what can cancel out here. The 80s can cancel out. All right, and then I could add the 1440 together and get 2880, and that just equals 2916 minus 9x squared. Okay, cool. So it looks like since we just have an x squared term, we're going to be able to utilize the square root property. Okay, so let's minus the 2916 from both sides. All right, and if I subtract that guy, we're just going to get negative 36 equals negative 9x squared. Okay. Divide both sides by negative 9. And we get 4 equals x squared. Man, this thing came out nice. Take the square root of both sides to get rid of the square. So x equals plus or minus 2. Cool beans. Yeah. Now let's just go back and read the problem again so we know what we found. So since we let x equal the rate of the current, we're supposed to find the rate of the current. Okay, so does it make sense to have a negative answer in the context of somebody or some kind of current that's negative? Well, it doesn't make sense, right? We don't have negative currents. They're always positive. You could say that one's faster or slower, but we don't have negative. So basically, the only answer is 2 miles per hour, not the negative 2 miles per hour. Okay.